Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 47 from the Smith Organic Chemistry textbook. This problem asks us to draw the products of each of these reactions, which involves an organometallic reagent. Okay, so we have 8 organometallic reactions here. So for the first one, we have a Grignard reagent, and we're reacting it with carbon dioxide, followed by some acid for the workup. And so this is going to result in the carboxylic acid. So remember, when we react a Grignard reagent with carbon dioxide, we end up with a carboxylic acid instead of like an alcohol like we typically get when we use just an aldehyde or ketone. So we have basically just replaced our MgBr with a COOH. So we have the carboxylic acid there. Okay, so that's A. B is a more typical Grignard reaction. So we have ethyl Grignard reagent, and we are reacting it with this ring system, this bicycle, and there's a ketone on the right ring, and so the reaction is going to occur at that ketone carbon, and so we will add our ethyl group from the Grignard reagent, and our ketone will end up as an alcohol. Okay, so there we go. That's B. For C, we're reacting an acid chloride with excess Grignard reagent, followed by water workup. And so here what we're going to end up with is a central carbon. And so we started with one phenyl ring, and our Grignard reagent is a phenyl Grignard. And so we actually end up with 3 phenyl rings on this central carbon, and then also an alcohol. Okay, for D, we're reacting an ester with excess Grignard reagent and then water workup. And so what we're going to get here is double addition of the Grignard reagent. So it's a methyl Grignard. And so we end up with our phenyl ring from the starting material. So there is that. And then here is our carbon that was the ester carbon. And so it's going to have an alcohol on it now. And we will have the 2 methyl groups that added. So one methyl group and a second methyl group. Okay, so moving on to the next page. So for E, we're reacting just a Grignard reagent with formaldehyde. And so the result of that reaction is going to be just the addition of one more carbon to this chain with an alcohol on it. And so we have 5 carbons to start. So our product will have 4, 5, 6 carbons and the alcohol. So 1 hexanol is our product. Okay. So then for F, we're using a copper lithium reagent. So it's the methyl organocuprate. And so the reaction here is going to take place at the double bond. So not the ketone. The ketone is going to be unaffected. And basically, we just end up adding a methyl unit to this chain. So it's an 8 carbon chain to start. 2, 3, 4, 5, 6, 7, 8, 9. So now it is a 9 carbon chain. The addition of that methyl group took place at the alkene. And so there is our ketone still intact. And so that's F. For G, G is just another typical Grignard reagent. So it's going to take place at the ketone in this molecule. Nothing else about the molecule, including that alkene, is going to be affected by the reaction with this Grignard. So there's the alkene still intact, as I said. And then here's the rest of our molecule. So our ketone has been reduced to an alcohol, and we've added a methyl group here. Let me move that down a little bit just so that it's easy to see. There we go. Okay, yeah, so we've added a methyl group, and our ketone is now an alcohol. Okay, and so that's G. And so lastly, we'll take a look at H. And so H, the organocuprate that we have here is going to act as a nucleophile and open this epoxide. And following the rules for epoxide opening, it's going to attack at the less substituted carbon in the epoxide. And so we will end up with this. So, oops. So here's our C6H5 unaffected by the reaction. Okay. And so again, the copper lithium is going to act as a nucleophile and attack at this carbon. And so what we end up with is an alcohol here. And there's our second carbon from the epoxide. And then since it was a methyl copper lithium or a methyl cuprate that we were using, there is our added methyl group. Okay, and so that's the product for H, and that's the answer here. The only, there's no secret to these. You just need to know how these organometallic reagents react under all of these conditions. And that's the answer to chapter 20, problem number 47.